In this example, we're looking at purchasing a new piece of equipment. The equipment has an installation cost of $655,000, depreciated to zero over its useful life of 5 years. It can be scrapped for $85,000 at the end of its useful life. It's going to save us $183,000 per year in pre-tax operating costs, and it requires an initial investment in net working capital of $35,000. So when we're looking at this, we're going to calculate. First, we're going to do the annual depreciation charge. So our depreciation is the cost divided over the useful life for straight line depreciation to zero. Next, we have the after-tax salvage value. So the after-tax salvage value is calculated by taking our pre-tax salvage value times 1 minus our tax rate. So pre-tax salvage times 1 minus the tax rate. And then our operating cash flows. So the operating cash flow is the operating cost per year times 1 minus the tax rate plus our depreciation shield. So we have our operating cost savings times 1, need parentheses, 1 minus the tax rate. So that's our after-tax effect of the change in operating cost, plus our depreciation shield, which is our depreciation expense times our tax rate. Okay. Now we have our operating cash flows for the next 5 years. We want to know what the net present value is of this project at a discount rate of 8%. So we can actually calculate this a couple of different ways. So first way is our initial, so our year zero cash outflows plus the present value of our operating cash flows for 5 years plus the present value of our year 5 cash inflow. Okay, so we have year zero cash flows. So we can do two things. We can do year zero, year one, year two, year three, year four, and year 5. Okay, and we can do all of our cash flows. So our cash out at year 0, we want that as a negative number. So it is the installation cost plus our initial net working capital. So that gives us our year 0. Then we have 5 years of cash flows, and additionally, in year 5, we get our after-tax salvage value plus the release of our net working capital. So the short way to do this is to do our year zero cash outflows plus the present value of the cash flows for 5 years plus the present value of the year 5 cash flow. So when we want, because we have 5 years of cash flows, we want a present value factor. So our present value factor calculation, that formula is 1 minus 1 plus the rate to the power of negative the number of years divided by your rate. And that's our present value interest factor. Okay, if we're doing the math out. Okay, so we take equals 1 minus 1 plus a percent to the power of negative our useful life, 5 years, divided by the rate. Okay, so we get a present value interest factor of 3.99. Then we have the present value of year 5. So our this year 5, where we get the $66.30 plus our $66,003 plus the $35,000. So year 5 cash flow is $35,000 plus from the release of net working capital plus the after-tax amount we get. Okay, so we have our year 5 cash flow. So our net present value is year 0 plus our factor times our cash flows plus our year 5 cash flow divided by 1 plus the rate to the power of 5 . Okay, and that is our net present value. The other way to do this is to put out all of the cash flows for each year. So we have cash flows in all of these years, and then we have in year 5, we have our regular cash flow, and we add this amount here. So then you can just use your regular net present value formula with the rate and the values plus the year 0. And you can see that the calculation is the same. So it's just the difference between if we just want to calculate it with these numbers here or if we want to type everything out. The next example, we're doing a sensitivity analysis and we're looking at how sensitive we are to changes in price. So what we do is we calculate out the price, what the cash flows are. So we want to know what the EBIT plus depreciation at 85,000 and 86,000. So the easiest way to get the operating cash flows is to just set up and calculate. So we have sales, variable costs, fixed costs, and depreciation. Then we get our EBIT, and then we want our tax rate. These are the numbers that we need. We have 85,000 units and 86,000 units. So we want the difference between the two. Then I'm just going to format. So this is a dollar amount. Okay, so sales, we have our units times our price of $39.20. I'm going to lock that so I can just copy that formula over, and it will do it for the 86,000 as well. Then our variable costs are the number of units times our variable cost per unit of $29.85. I'm also going to lock that. The fixed costs are exactly the same for both, and our depreciation rate is straight line to 0. So the cost divided by the useful life. So sales minus the total of all of our costs gives us the EBIT amount, and then the last number we need is our tax amount, which is our earnings before income and taxes times our tax rate. Lock that tax rate cell, and then we can copy that over. So our operating cash flows at 85,000 is our EBIT plus depreciation minus taxes. And at 86,000, the earnings before interest and taxes plus depreciation minus taxes. Here we want the change in operating cash flows divided by the change in quantity. So we're going to take operating cash flows from 86,000 minus the operating cash flows at 85,000 divided by the 86,000 units minus 85,000 units. And we get $7.20. So our operating cash flows will increase $7.20 for each additional unit sold. I'm going to start a new video for the last example because the last example is much larger than these examples.